Hey guys, how's it going? So in this tutorial I'm going to show you guys how to perform a linear fitting on a set of data using Origin Pro 9. So for this tutorial I'm using Origin Pro 9. However, this functionality has been there in Origin for quite some time now, so you can use this tutorial to help you out even if you have a previous version of Origin or any different newer version, because I think the procedure will remain approximately the same, so you can follow this tutorial regardless of the Origin version you have. So let's say you have some data on which you would like to perform linear fit. So I have that here in an Excel file. So just go ahead and select it and copy it. Then switch over to Origin and then select this worksheet and click on the first column, and then just click on Ctrl+V or just right click and paste the data. So you can do either way. So you will have all this data right here. So then you can just go ahead and select these two columns and then right click on these, plot these using a simple scatter plot. So this would show you a nice little scatter plot for your data. Then just go ahead and analysis and then select fitting and go to linear fit and open the dialog. So this would basically pop up a small window asking you to select some of the to make some changes to the settings or select some range on which you would like to perform the linear fit. However, for the sake of this tutorial, let's just see what happens if you just go ahead and click on OK without changing any of these quantities or making any changes here. So currently it has selected all the data that you had, so it will perform a linear fit on all the data that you had. And let's just go ahead and click on OK. So when you click on OK, what you can see is that you have a nice little report showing you the various aspects of the linear fitting that Origin has done. So basically the slope comes out at about 0.99485 and the intercept is 0.55. So slope basically is for a line equation given by y is equal to mx plus c. Slope would be m and intercept would be c. And if you compare the result with the Excel result that we got here, so let me just arrange these window a little bit and then just show you the results. So we got pretty similar results using Excel and Origin. So we got 0.9948x plus 0.5573. So that is basically pretty much similar. And then you also have the residual sum of squares. You have the number of points, degrees of freedom, because there are two constraints, so therefore the m and c, therefore the degree of freedom would be 8. And then there is the adjusted r-square value. So there's everything that you would like to know about linear fit. And then there is also a fitted curve plot showing you the data as well as the fitted curve. So basically this is all you would probably need in your practical use. However, now what we can do next is we can come back to a graph that we plot, and you can notice that there is also a small data table that Origin has provided you with. So you can just put it on the side. Now in this way what we have done is we have performed the linear fit on the whole data. But what if you want to perform the linear fit only on a smaller subset of the data? So then what you can do is you can basically beforehand you can just select the data using the regional data selector, and maybe let's say we will select these 3 points in the middle. So just go ahead and select those like this. So now you can see that these 3 points have been selected, and then click on analysis, fitting, linear fit, open dialog. So this time what you would notice is that the range of the second column has been reduced. So now it is only considering the 5th, 6th and the 7th data point for the linear fitting. So now you can just go ahead and click on OK, and again you would have a different plot for the fitted for the 3 data points. So this time the equation would be drastically different. The intercept and slope values are different, and this time if you look here, then you will see there are only 3 data points used for the linear fit. And then coming back to the graph, again you have a nice little table showing the data, and then you have another line showing the linear fit. So you can even change the color of that and then just increase the width to Okay, so now the two data points or the two fitted curves can be distinguished easily. So that's how you would go about performing a linear fit. And then there is also a bunch of other options here in the dialog box that you can use to perform a fit according to your needs. So there is an option to fix the intercept, and you can choose where you would like to fix the intercept. This is pretty basic in most of the softwares. And then there's another option to fix the slope, which is not really found in a lot of softwares. So you can do either of these. And then there are other options too that I will not be going into, because I don't think there is a lot of need to tweak or play with these. However, you can do or play with these to perform a linear fitting according to your needs. And then there are options to select which kind of residual analysis you would need. There are output settings, how would you like to arrange the graphs and whatever. So there's a lot of stuff here. There's also an option that asks you if you want to plot the fitted curve or not, so you can uncheck that if you don't want to see the plot and only want the equations. And then there are further settings on how that fitted curve should be plotted. And then there are a few more settings on find x or y and stuff like that. So that's it, I guess. So that's how you perform a linear fit using Origin Pro 9, or any other version of Origin should probably have this feature in a similar manner. So that's how you would do that. I hope you guys enjoyed this tutorial, and in case you did, then don't forget to hit the like button and subscribe to my channel for more videos like this. I also have videos showing how to perform a polynomial fit or some other kind of fit using Origin, and a lot of other useful stuff. So I hope you guys like this video, and don't forget to smash the thumbs up button and also the subscribe button. Thanks for watching and have a great day.